Let us start sets and relations. What is a set? A group of well organized and well defined things is a set. For example, say a group of cricketers, okay, or Indian cricket team. You know, Indian cricket team means Dhoni, Yuvraj, like kind of that. It's well defined. Okay, that is a set. Okay, and everything has to be distinct in a set. Well defined objects. Okay, and if you have two sets and if you have a link between them, that is called a relation. For example, I have a set of cricketers here and I have another set which is called a bowler, batsman, fielder, wicketkeeper. Okay, say Dhoni, Sachin. Okay, these are two sets. Now they have a relation between each other. Dhoni, wicketkeeper, and batsman, Sachin, batsman. There is a link between both the sets. That is called as a relation. But as you see here, okay, let me say there is some other player who is Ranji. Okay, some other player. He is none of these. So it means that every object here need not have an image, or it can have any number of images, not just one image. Okay, now we define something called as a function. Okay, why we are defining function? According to function definition, if there is any image, this is called pre-image and this is called image. Okay, any object here can have only one image. I am saying one image. Okay, it means it should have an image, because if it doesn't have an image, it means zero images. So basically, you can define every object here has one image there, but it doesn't mean. But it also can be like all the objects can have same image. But thing is, one thing should have only one image. That's why root. Okay, if x square equal to 10, if you put square root is not a function. Why is it not a function? Because root 10 can be minus root 10 or plus root 10. That's why it's not a function. But square can be a function. Say y equal to x square. It is a function. Why? If you take 10 square is only 100. There is no other value. Okay. Now defining, see here. This set and this set have finite number of elements. Now if you want something which has real numbers are, it's not a finite set. So many numbers will be there. So we would like to have something, some other representation other than boxes, because they cannot accommodate this. Say we can represent this set as x, this set as y. The function can be expressed as y equal to f of x. This means do some operation on x, you will get y, which is an element here. X is a general element here and y is a general element here. For example, if I have 10 here, it is mapping with 100. I have 4 here, it is mapping with 16. Okay, so what is the link? Y equal to x square. That is a function. So like that you are defining some procedure to get y from a known value of x. That is called as y equal to f of x. F of x means the procedure which has to be done on x in order to get y. Now what is f of x? That is f of x. Now what is f of x? We told it is x square here. So f of x square. Now what is f of x square? X square whole square. So that is x power square. Again we'll see what is f of x. And then you will do f of x once. On that f of x, you are doing again f of x. Now let us take two functions. F of x equal to x square, h of x equal to x cube. Now what is f of h of x? F of h of x is f of h of x. F of h of x. What is h of x?
H of x cube.
So f of x cube. Now what is f of x cube?
X square plus whole cube.
F of x is x square. So f of x cube will be see, if I say f of x is x square, it means f of a square. It is giving a procedure. So if you have something inside this, how to find that outside? So what is this f of x telling here? It's telling inside the bracket, if I have some number, square it to get the image. Here what is it telling? Cube it so that you get the image. Okay? So what is f of h of x? F of x cube whole square. So what is that? X power 6. Now what is h of f of x? H of f of x is h of x square. Now what is h of x square? X square whole cube. So it is x power 6. So here f of h of x equal to h of f of x. But it's not true always. Here it is polynomial. So we are getting. Now let us say f of x is x square plus 2. H of x is 1 by x. Now what is f of h of x?
F of 1 by x.
F of h of x is f of 1 by x. Right. Now what is f of 1 by x? 1 by x square plus 2. So f of h of x is 1 by x square plus 2. Now what is h of f of x?
H of x square plus 2.
H of x square plus 2. Now what is that? 1 by x square plus 2. So here f of h of x is not equal to h of f of x. Now you cannot come to any conclusion regarding this. Just check and see whether f of h of x equal to h of f of x or not. Just check it out manually. You cannot say. But as far as polynomials are concerned here, not polynomials, some x power m, you will always get it. Because x power m whole power n is x power mn. That can also be written as x power m whole power n. That's why you are getting it this way. But it is not the case always. This is a special case where it is actually satisfying that. So please remember that you cannot write it that way. These are called as composite functions. Composite functions means you are applying a function once. It's like this. This is a function. You have one set. On that you are applying one function. On that function you are again applying one more function. Now what is this f of x? This is x. This is f of x. That is giving you f of x. Now say that f of x was there in this also. For example, say f of x equal to x square. Okay. Now let us say there is 2 here. 2 is becoming 4. 4 becomes 16. I am applying f of x here and here. Okay. X square function. Okay. Now 4 is there here means 4 is giving you here 16. So f of x could well be there in the value of this also. Okay. Now let us take some definitions on this. All the set which is from where you are mapping is called as domain. The set of elements in this is known as domain. Okay. Now what is the important condition? Every object in the domain should have an image, and that too one image, only one image, and this is called as codomain. That is to which it is mapping. And the domain, codomain. Now don't confuse codomain with range. What is range? Range means the set of elements which have a pre-image. That is the set of elements which are mapped. For example, this is f of x equal to x square. I have -1 here. -1 won't have a pre-image because this is real number set. So -1 won't have a pre-image. But it doesn't mean it's not a function. This is a function because each and every element in this set has a image in this set. Got it? So range need not be equal to codomain. Got it? Every element need not have a pre-image, but every element in domain has to have an image there. Okay? Now let us take a few definitions of different types of functions. Now, if there is something called as one-one function. If every element in the domain has only one image in the codomain, that is known as one-one function. For example, y equal to x plus 2. Okay? Only if you take this, if you put x equal to 1, you get 3. For any other value of x, you don't get 3. Okay? So what does it mean? If f of x1 equal to f of x2, it implies x1 equal to x2. Okay, let me explain you the meaning of this. It means that no two different values of x in the domain have the same image. Okay, so if f of x1 equal to f of x2, that's not possible if it is 1, 1. When is it possible? It's possible only when they are equal. Okay, let us, is y equal to x square a 1, 1 function? 2 and minus 2 give you 4. So it's not a 1, 1 function. Now let us take a foolproof method to actually find whether it is 1, 1 function or not. Okay. So we are saying definition of 1, 1 function as f of x1 equal to f of x2 implies x1 equal to x2, and most importantly x1 x2 belong to domain of f of x. Okay, they should belong to domain. For example, I defined y equal to x square. I took domain of x as real numbers. So it means that imaginary numbers or matrices should not be considered as x, because they are not a part of the domain. So you can't substitute this for imaginary numbers. So let us see if x square is a...
Wait, the first set is called as a domain.
Yeah, the one to which it is mapped is codomain. And the set of things inside it which are pre-images or which are mapped, they are called as range. For example, y equal to x square.
And if three sets are there, the third set is also called as a...
there is no definition for that. Okay, we define only for one function. We do not define for composite function. For composite functions, you need to take each one and see. Okay. For example, you take y equal to x square. I am saying it maps. You should clearly specify domain and codomain. Let us say this is how they say. F, they put 2 dots. It stands for maps from R to R, which means R is domain and R is codomain. I wrote it like this, and then I write f of x equal to x square. This is the procedure with which you will actually define a function. F maps from R to R. This is codomain and this is domain and this is codomain. And this is the function. Now I want to check whether it is 1, 1 or not. So f of x1 equal to f of x2 should mean x1 equal to x2. Now let me see. F of x1 equal to f of x2. So what does it mean? x1 square equal to x2 square. But does it mean x1 equal to x2? It means x1 equal to x2 or minus x2. So it means it does not imply x1 equal to x2, which means two different values can have the same image. So it means f of x equal to x square is not a 1, 1 function. Now let us see f of x equal to x plus 2. Same thing, f of x1. Again remember, f of x1 equal to f of x2 implies x1 equal to x2 for x1, x2 belongs to domain of f of x. Do not substitute any value of x1 and x2 which do not belong to the domain of f of x. For example, if I say f maps from R plus to R, then is it 1, 1? It is. Why? 2 will give you 4. Minus 2 was giving you 4, but here minus 2 is removed from the domain. That's why I am telling x1, x2 belongs to domain of f of x. say f maps from R plus to R, f of x equal to x square. So f of x1 equal to f of x2 for all x1 x2 belongs to domain of f of x. So x1 square equal to x2 square. Now we know x1 and x2 are positive. So it means x1 equal to x2. x1 cannot be equal to minus x2. Because see, if x1 equal to minus x2, x1 is positive, x2 is positive, but there is a plus here, there is a minus here. Or you can say x1 plus x2 equal to 0. Sum of two positive numbers is 0. So it means x1 equal to x2 equal to 0. Again x1 equal to x2 you got it. So it is 1 1 if it maps from R plus to R. So make sure you substitute f of x1 equal to f of x2 implies x1 equal to x2 for x1 x2 belongs to domain of f of x. Generally students ignore that x1 x2 belongs to domain. You should not ignore. Okay. Now the next one is called as onto function. Now we saw that range need not be equal to codomain. If range is equal to codomain, then the function is known as onto function. F of x equal to x square. Okay, f maps from R to R. F of x equal to x square. Is it onto? Now first you need to find the range. Y equal to x square. So y belongs. What is range of y? Y is greater than or equal to 0. A square is greater than or equal to 0 because x is real number. Square of any real number is positive or 0. 0 is not positive, not negative. Okay. So what is range? Range is R plus union 0. Union means combination of two sets. Ante all R plus as well as the element 0. Element 0 is written like this. Okay. All positive numbers as well as 0. Okay. What is intersection?
Common.
R plus intersection 0 means the things which are common between this set and this set. This is called as intersection, this is called as union. What is intersection of R plus and 0? Null set. Null set. Null set means nothing. It is represented by 5. Okay, this is called 5, it's a Greek symbol. Okay, so range is R plus union 0. But what is codomain? R. So is it onto?
No.
It's not onto because range is not equal to codomain. How do I make it onto? If I say f maps from R plus to R plus, then y is greater than 0. Why? Square of any positive number is greater than 0. So range is now R plus only. And what is codomain? R plus. So now this is onto. So just when I say y equal to x square, you can't comment whether it is onto or not. You need to see domain and codomain to actually comment whether it is 1 1 or onto. Y equal to x square can be made 1 1, can be made onto by adjusting domain and codomain. So never make this mistake of just shouting whether it is 1 1 or onto by just looking at the function. You need to look at the domain and codomain. And generally by convention this is domain and this is codomain. This is not range. Generally by convention this is codomain. Okay. Now if a function is 1 1 as well as onto, it is called as a bijection. Okay, now what is the advantage of it being a 1 1 as well as onto? Let us draw a map diagram. Just like how when we were defining functions, to get clarity we drew diagram like this. So what does it mean? If you consider any element inside this, it has only one image. And you know that everything here has one image in this, one pre-image. So what does it mean? You can come backwards. You can have a function from behind. For example, you see y equal to x square. It's not y equal to x square, f maps from R to R. Okay. You have 2 here, you have minus 2 here. Both are giving you 4. and you have -1 here, nothing here. So for -1 you can't find a function from this to this, because for -1 there is no image, for 4 there are 2 images. If there are 2 images, that is not a function. Okay, but if you take y equal to x plus 2, say you have 2 here, you will get 4. If you have 4 here, you will get 6. Now if you have 4, you can come back with a function. What is the coming back function? F inverse x equal to f of x equal to x plus 2. F inverse x is x minus 2. Okay. Now let us try to see a foolproof method. First thing, if they are asking you f inverse x, you need to check the domain and codomain to see. First thing is, I should tell you f maps from R to R, so that it's 1, 1 and on 2. Should check domain and codomain whether it is bijection or not. What is bijection? 1, 1 as well as on 2. Once you see that, then you can tell whether f inverse x exists or not. Now, how did I get x minus 2? Let us see a procedure to actually get it. F of x is x plus 2. Okay. Now, I am giving you value of x and you are finding f of x. Now you should find x by knowing value of f of x. So x equal to f of x minus 2. So x is giving you f of x. For inverse function, you are putting f inverse. F inverse of f of x gives you x. X, while putting f function, is giving you f of x. On f of x, you are putting f inverse, you are getting back x. So f of f inverse x is x. Now f inverse of f of x is x. Now what is f of f inverse x?
X. No. F of x.
Let us see it from the base. You want f of f inverse x. Now there is x here. Further there is f inverse x here. Why is it x? You know f of f inverse x is s. Just now we proved. Okay. Now what do we need? F of f inverse x. So it's x itself. Okay. F of f inverse x. We need to prove it. First, let us see an example. Let us say y equal to x plus 2. What is f of x? X plus 2. What is f inverse x? X minus 2. We want f of f inverse x. So we want f of x minus 2. So it's the f of x minus 2 is x. Now can you prove it using this method? X is giving f inverse x. F of x of f inverse of f of x is x. In such a way, if you have f inverse x here, by putting f, you have f inverse x here, by putting f, what do you get here? X. How can you say? Give me a proof. Okay, first let us see what is the use of this bijection. Okay, the use of this bijection is actually you are assured of one image and you are assured that this side there will be an image when you come backwards. So the main use of bijection is you are able to get an inverse function. Now what is the use of this function? Why do we use functions? You see, many times they will tell you if a equal to x, adding 2 on both sides, a plus 2 equal to x plus 2. But what are you doing there exactly? You are actually applying a function. See, if there is one definite value of x, okay, then f of x has only one value. Let us say x equal to 2. F of 2 has only one value, which is in the codomain, just one value. For example, f of x equal to x square. If x equal to 2, f of 2 equal to 4, that's it. It cannot be 4 and 8. For example, if I say f of x is defined as f of x whole square equal to x. Then if x equal to 4, f of x can be either 2 or minus 2. So that's not that's not a function and you can't apply it. Now I hope you are getting it. For one value get only one value. So you know a equal to x. A is any part of a and x are equal and they are a part of the domain. So you are applying function f of x equal to x plus 2. So if they both are equal, their image should be equal as well. But say you are applying root x. You have 2 square equal to minus 2 square. Now if you apply the relation root x, okay, root of 4 can be 2 as well as minus 2. So you can take anything on both sides. You can take 2 equal to minus 2. But it is wrong. Why? It's not a function. You can only apply function on both sides. You can't apply a relation on both sides because relation can give for same value there are two things. So on LHS it can give this, on RHS it can give that. That's why you cannot apply a relation on both sides and you can only apply a function on both sides. That is what you are doing. Now a small example, AX equal to BX. Now you are applying the function 1 by x on both sides. Okay, you get A equal to B. But it is not the solution. So what went wrong there?
You applied a relation.
When x equal to 0, it's wrong. When x equal to 0, A need not be equal to B because 1 into 0 equal to 2 into 0. It does not mean 1 equal to 2. I am applying 1 by x on both sides. 1 by 0 I am applying. But y equal to 1 by x, in that function x will not be x equal to y equal to 1 by x. In that function x equal to 0 is not a part of the domain. Why is it not a part of the domain? 1 by 0 is not defined. See, you tell 1 by 0 is infinity, but infinity is not a number. Infinity is a concept. And again 1 by 0 is not infinity. 1 by something which is almost 0 is infinity. If you draw 1 by x graph, you see 1 by x, when x is very small and positive, it will be plus infinity somewhere. And as x increases, 1 by x decreases. As x becomes big and big, it becomes almost 0. When x is negative, 1 by x is negative. It's almost minus infinity when it is almost 0. And when it is going towards minus infinity, it tends to 0. So 1 by x, it's something like this. So at x equal to 0, it has no value. So it is not defined at x equal to 0. That's why you cannot apply the function 1 by x when x equal to 0. So how do you solve such a problem? You take two cases. Case 1, x not equal to 0 and you apply the function and you get a equal to b. Case 2, x equal to 0, that's it, that's the solution. A and b cannot obtain any relation if x equal to 0. Okay?